All right. Hello, everyone. Welcome to another session of ExpoLab Blockchain Speaker Series. And today is my great pleasure to have Khoury joining us. He is from Celo and he is in charge of developer relation. And prior to that, he was at Ethereum Classic, again focusing on engineer relations. And so he's going to talk about the key topics of stablecoin and payments in the blockchain space. And so excited to have you. And so please, without further ado, take it away.
Well, thank you for having me, Mo. I'm very happy to be here. Excited to go over this lecture. So uh, the topic for today is stable coins and payments. And basically, what I want to go over is just like basically brush over stable coin, different kind of mechanics and stuff. And with that, introduce Celo as a consensus mechanism and architecture and everything related to the stability protocol and stuff. Mo already gave an introduction to me, but if you want more detailed, I do developer relation currently at Celo. Been with Celo for the past 3 months. Before that, 2 years in Ethereum Classic, and before that was software engineering. And my background before then was robotic engineering, and so I've been all over and stuff. I have a bunch of interests, mostly board games. So if anyone wants to play Catan after this class, hit me up. So the agenda for today, I'm going to go introduction over stablecoins, and then we're going to talk about after we introduce the stablecoins, we're going to introduce Celo. After that, going to go over the stability protocol overview, and then I'm going to brush over consensus. Then after that, we're going to talk about the mobile first strategy at Celo. And we're going to also do a little minor comparisons to other networks. Um, then I'm going to show a bit of case studies as well, and we can do a Q&A at the end. This is by no means, you don't have to wait until the end to do Q&A. Like, it's informal, just hit me up whenever, stop me anytime you have any questions. I'm more than happy to answer. All right, so let's do an introduction on stablecoins. I'm kind of curious. Did anyone heard of stablecoins before? Any takers?
No, I haven't.
Awesome. Yeah. So, like the stablecoin have been, really popular. Like there was the popularity recently around starting in 2017, just in terms of volume and usage, and moving to 2020. And recently, I don't know if anyone saw the Stable Act. That showed how much of an impact stablecoin has been making in the market. Right? But what is a stablecoin, right? So at the highest level, it's just a cryptocurrency. From a technical point of view, a stablecoin is a cryptocurrency. It's been designed to be on the blockchain and stuff like that. It's a digital currency. But what makes it different than other cryptocurrencies? Like, what's the point of a stablecoin? It's designed to minimize volatility. Now, with Bitcoin and Ethereum, one of the biggest friction in order for adoption, at least with like the mainstream users, is volatility. Users are not comfortable with the price swings and stuff like that. Um, Other users were more concerned about the whole transition from crypto to fiat and back to crypto as traders or people who want to park their money but not necessarily move it to fiat directly. Reasons being tax purposes, just because um, if you trade it to fiat, you got to pay incur tax fees, and you want to go trade back and forth. So stablecoin provide them like a temporarily good place to park your asset before you finally decide to liquidate. Other things are also there's like fees in fiat and stuff, and stablecoin don't necessarily have that much fees, relatively speaking. And the main point of a stablecoin being stable is that it's spec to an asset. Like the asset could be anything, but the most popular asset right now is the US dollar. And That's the asset that, because the US dollar is like most recognized globally and stuff, it's the most popular asset that you would want to peg a stablecoin to. So I'm going to brush over examples of stablecoins. The most popular stablecoin to date is Tether, USDT. There's also USDC, which is created by Coinbase and Circle. DAI is the most most popular one initially for as a decentralized stablecoin created by MakerDAO, and Celo dollar CUSD, which I'm going to cover as well later on. But let's talk about Tether before we jump more into stablecoin. So Tether initially was created in 2014 by a company called Tether Limited. And the whole idea of Tether is that for every USDT minted, you would keep, the Tether Foundation presumably would keep 1 USD in reserve. So that would allow for one-to-one backing and stuff like that. When it launched in 2014, it had like small amount of supply that slowly kind of grew, but it really wasn't really popular until 2017. That's around the time when Bitcoin's price went up and stuff. So there was more demand for a stablecoin in order to trade it back and forth for Bitcoin. There's been though, like Tether, issue with Tether is mostly from legal perspective. So like the New York Attorney General claimed, like I believe back in 2018, where claiming that the Tether Foundation, or I think it was Tether Limited, were using some of the asset that they're holding to pay off their losses and stuff. And that kind of like, it was coupled with like worrying speculation about how much Tether really holds, the foundation, how much does it really hold in reserve. And that didn't help when the Tether Foundation claimed that actually it's not one-to-one. They hold 0.74 cents for every USDT in an account. So it's not even one-to-one. So that's the problem, I think, as well, with having a centralized off-chain, like kind of like stablecoin, where you have to hold like USD in a reserve in order to match the USDT. Let's see. So we talked about the volume, like just to compare volume, if you look at, this is from Coin Metrics. If you want to check out the report, The Rise of Stablecoins, it's a report, a PDF report, I highly recommend it if you want to read more. Here you can see that since 2017, there's not been much volume, like barely in the millions, right? But this is like, it grew around then. Slowly around 2017, and now, like, you know, with the other stablecoin that are in the picture in late 2018, that's around the time Gemini USD and USDC were coming around then. That's when they started growing and stuff, along with MakerDAO and stuff like that. But it should give you an idea about how big the market is for Tether. It hit 12 billion, and it's probably even higher right now in terms of supply volume. What are alternatives to Tether? So when I'm talking about alternative, I'm talking about alternatives that are trying to do one-to-one matching using fiat currency to back their stablecoin. Other alternatives are USDC, which is the Circle plus Coinbase. You can actually use USDC now if you have a Coinbase account, and you have Gemini dollar, GUSD, which is held in the Gemini exchange. MakerDAO is really interesting. MakerDAO created what is essentially the first decentralized stablecoin asset. It's the native stablecoin is called DAI by the company Maker. DAI is pegged to the dollar, and it uses what we call an oracle to call up and, you know, get the latest prices and stuff like that, just to do matching and stuff for Maker. It's what's interesting about DAI when it first came out, it wasn't backed by US dollars in an account, it was backed by Ethereum. So users were able to deposit their Ethereum in a smart contract in what we call a collateralized debt position, or CDP. and were able to withdraw DAI as a debt on their debt positions. And it had a really interesting mechanics and stuff where around the stabilization fee, where if if you go below a certain ratio, depending on how much you're withdrawing in debt or on your peg position, if you go below that ratio, you can get liquidated, depending how much you withdraw. If you withdraw less than the, if you don't withdraw, if you withdraw less, you don't necessarily get liquidated. At the same time, if you can hedge by adding more to your debt, by depositing more into the contract. I'm not going to go too much over DAO, the MakerDAO, but there's a lot more better resources on MakerDAO. But like the point is, just wanted to bring like it's a decentralized stablecoin in as a comparison to all the other stablecoins that we already talked about. Celo dollar is another variation on decentralized stablecoin. It's a native stablecoin asset on Celo, and it's also pegged to the USD. Now, we're going to talk more about Celo later on in the lecture, but if you wanted to brush over what it is. Before we continue, and again, like I highly recommend going over that report if you want to dive more into depth about it. But the March 2020 effect on stablecoin was really, really interesting because around then you had like COVID, you had the oil future like dropping negative. There was a lot of uncertainty in the market, and it showed in making stablecoins unstable. And the biggest ones that to be highlighted are Gemini USD, which is this one. It's like around like the March 12th drop. If you see like just in terms of the price, it went from a like peg to the dollar to 0.9 for a while, and that is because there was not a lot of supply and there was not a lot of liquidity. I mean, at the Gemini exchange, and there was not a lot of demand. So even with the drop in stock, there was in March 12, it really affected Gemini USD. If you look at like the total volume, like the total supply is about 5 million, compared to other bigger stable coins who have like over 100 million and stuff. So it's kind of like an indicative of that. DAI, if you look at DAI here, going over 1.05, it was really around then, it was like, it became, it got a little bit higher. And that was due to when there was a panic in the market and stuff like that. What happened was more people wanted to liquidate their debt positions. And because of that, and because there was like a certain requirement to be kept by the governance protocol for Maker, it led to a shortage of DAI to be issued. And adding on top of that, congestion in the network from gas fees and stuff, and all that panic, and there was a shortage of DAI, which kind of increased the price to 1.05, which is higher than the dollar. It would peg to, and that's really interesting and stuff. MakerDAO actually talks a lot about this phenomena after in retrospect and stuff, because a lot of things happened that nobody anticipated. But to be fair, March 11 to 14, that period was a really interesting period in 2020, at least for outside of stablecoin and stuff. So nobody could anticipate these kind of behaviors. All right. So with that said, I'd like to start, talking about introduction to Celo. So Celo is relatively new.
I think there's a couple of interesting questions. So Zach, and so why don't you ask your question?
Oh, let me see. I'm sorry. I haven't been looking at the question.
No, that's okay.
Here, I can just ask it to you. I was just thinking, it seems like, cryptocurrencies and those type of things are like replacing physical things we have in this world, because maybe we don't trust, institutions or centralized things.
Mm-hmm.
And so I guess I was just wondering what, it feels a little, maybe not pointless, but weird to invest time into stablecoin when it seems like, stablecoin relies on the thing it's trying to replace, which is like maybe physical currency. Maybe that's just such a far out future that it's still relevant, like it's still totally okay to do stablecoins. But I guess, what do you think is the long-term relevancy of a stablecoin if it relies on maybe what it's kind of trying to replace?
Yeah, I think that's a really good question. Thank you for asking this. I wouldn't think that stablecoin is trying to replace US dollar. I don't think that's the aim of a stablecoin, at least from my personal opinion on this. Compared to like the Bitcoiners, like, oh, we really want to replace the US dollar, like all the, it's more like a libertarian kind of culture in Bitcoin. Stablecoin, what are interesting about stablecoin, at least in theory, it allows um, folks to be exposed to a stable currency outside of the one that they might be exposed to that have higher inflation risk. For example, Venezuela. Right now, you have USDC. It's collaborating with the U.S. government. I believe it's the U.S. government. But USDC is right now being sent to Venezuelans who are like really affected by inflation and stuff. So us in North America, yeah, I mean, like from a high level stablecoin, then we don't really like. I mean, I like Venmo, honestly. Like it works really well for me in the U.S. and Canada. Um, and credit cards work well, but stablecoin can, as a promise for unbanking, no, banking the unbanked, it shows that you can allow for more accessibility to stable currency in global region where people don't necessarily have an access to a bank account or don't necessarily have the requirements in order to open an account that would allow them to buy US dollars. And also, I mean, look at Lebanon as an example. They stop you, if you're in Lebanon and you're allowed, I think $200 USD withdrawal per week that you can pull out of the country and stuff. And that's insane. Like, I mean, if everything that you have saved, you can't really withdraw it, like, legally because there's a limit imposed by the bank, but yet you want to still be exposed to that stable coin price as a digital currency. There are certain use cases. And it's a great question. I like it because it actually goes well with what I'm trying to, introducing, Celo and what we like the whole mission that we're trying to do behind it. But I hope this answers your question at least.
Yeah, cool. Thanks.
My pleasure. Is there another other question?
Yeah, I had a small question, but it was kind of similar to the question that was just asked. I just asked if by stablecoin, and I asked this kind of at the beginning, if that means that the coin avoids like major increases in value and also major decreases in value. Because when I was first thinking about it, I was thinking like one of the major selling points of a lot of cryptocurrencies is that they're going to replace standard currencies. So there's going to be a major increase in values, which is why people should adopt it. I thought it was kind of funny that you mentioned Venezuela because I remember I heard a couple months ago they're trying to rebuild their economy with an Ethereum backing now. So I was just kind of wondering like how, like what would be the incentive to adopt it if we're not going to have any major, like, I don't know, increase in value as well as decrease.
Yeah. So a stablecoin, yeah, like I think what I brushed over before is, yeah, it's not the best asset if you're hoping that it's going to double in price, because that's not the point of a stablecoin. It's more if you want to park your money in crypto without having necessarily to use fiat. And this is just an example for folks like us, like in North America, who are like, who don't necessarily have to care about the inflation aspect of other currencies, which is why we prefer like a USD stablecoin. But for us, it's a way for us to get liquidity, get a stable currency on chain without having to withdraw back to US dollar, incur fees, having to pay taxes after that too soon. Like maybe you want to like liquidate 10 years from now, but you still want to go back and forth trading, or like, park, like let's say you're investing in another asset that is not a stable coin but is more volatile, but like after a while you want to pull out of that asset because you just for the time being, but you don't necessarily want to go directly to USD and withdraw your money. So that's where a stable coin can be really valuable as well.
All right, thank you.
Right, cool, thank you. So yeah, with that, I also want to introduction to Celo, and I want to talk about our mission and like how it came to be and stuff like that. And let's go from there. So what is the mission of Celo? Our like Celo, what I really like about Celo compared, and I'm not saying this because they pay me to say this. No, I say like I'm saying this because I truly believe in that mission. Having been in crypto for 3 years and stuff, I really think that sellers trying to do things really differently. They want to, like, the mission statement is to create a monetary system that creates the condition for prosperity. So what are the conditions for prosperity here? Allowing folks to be able, like we talked about earlier, I mentioned about how like the inflation and stuff, people can get really affected by inflation. I've known so many people who got affected by inflation in other countries and stuff like that, losing the value of everything that they hold dear and everything they've saved in the bank goes down in value overnight and stuff. And they don't have necessarily are allowed to open a USD account, or they can't really trade in US dollar, or they can, but the governments of the country that they're in don't, they have a strict limit on where you can pull out the money out of that country in USD and stuff. And so, there's a lot of different factors here. So the whole idea of creating conditions for prosperity is to allow, at the basic level, anyone who has access to a mobile phone be able to use a stable coin. So the whole idea of this is, like, in a nutshell, at least with our product Valora, is we're creating Venmo without a bank account. That's the whole, like, from a high level, like how would you like, and that, it can be used globally and stuff. Anyone can download it on the App Store and stuff. And we're going to talk more about the mobile stuff, but I just want to brush over the mission. The mission, I've never worked with a team that is more mission aligned than the Celo team. And I'm really excited to talk more about this later. Let's see. We're going to talk about the architecture overview now. So we like to think of Celo as the first mobile-first blockchain. It had a strict aim on mobile first. From a consensus point of view, we're a proof-of-stake network. And we can talk more about the proof-of-stake protocol itself. Also, I'm not going to really rush on this bit, but like in case, I'm more than happy to answer questions on it, but it's an EVM-based network. So what is an EVM? EVM stands for Ethereum Virtual Machine. And there's a lot of there's a lot of blockchains that are following that kind of practice. So an EVM allows you to run smart contracts like Solidity, Viper, and on the network. And it's currently, in my opinion, as EVM-based networks are the golden standard of smart contract. There are, attempts to improve it with different languages, different stuff. And I think that's an effort to go in the right direction, but I still think that the EVM is the golden standard right now. So just to brush over the architecture as well from a high level, and I think visual descriptions are better than text. At the core center, we have validators, and a proof of stake network, they're the ones who are validating the block. They're taking all the transactions that are between people back and forth, and they're the one who staking, earning a reward just in order to validate the network. You have full nodes that are able to, they keep copies of the network and stuff like that, which enables light clients to work with full nodes in order to get, the whole, transaction history. The light clients are at the mobile level. At the mobile level, if you have an application, I'm sending $5 to somebody else and stuff, that's the transaction on chain, and that one will be move to the, a validator will take that transaction along with other transaction and propose a block, and other validators will approve the block as long as we reach a quorum, and then that block gets added to the blockchain ledger and everyone updates, and that all happens automatically. So the first innovation that the whole architecture system proposed is something that we call address-based encryption. So what is address-based encryption? Before we talk about address-based encryption, we can brush over identity-based encryption. So identity-based encryption is like, at a high level, you know, I have an email, you have an email, I want to send you $5. I don't want to, like, as a user experience, I don't want to create a private and public key encryption. So most centralized non-crypto services would allow you to do that, but they have an encryption layer that they add themselves. And what they do is they take your email, the recipient's email, they encrypt it. The problem with this approach is you're adding a third party that's doing the whole encryption, doing the private and public key encryption just to connect the dots and stuff. So you don't have to do it. And but the benefit of it is you as the user, you just care about somebody's email. Like, I want to email somebody $5 and stuff. So what we proposed, we wanted to take something where we call address-based encryption, which is a modification on identity-based encryption. So we still take the public-private key encryption scheme, which is what everyone else in crypto does. You generate a private, you generate the private key and you have a public key, and if you know somebody else's public key, you can transfer money back and forth. But here, the user is still doing the same thing. But after they create the public key, they're going to register the address of their public, like they're going to like the email address to the public key in a smart contract. The smart contract here is taking place on behalf of a decentralized blockchain layer. So after that, we do something that we call attestation, where the attestation is how do we ensure that, or attest that this is a valid address to public key. And this is where the validator would have to send in a text message to the person who wanted to do the attestation, and the assigned text message, and the user would have to send another text message, signed with their encrypted key, to the attestation smart contract, which is the one here. And that would verify, the smart contract would verify the address to public key based on the signature of the validator and the user. Using this scheme, we don't have to limit it to phone number. It can work with email, two-factor authentication and stuff like that. I'm going to show you like an overview from like a design, just like a diagram on this, just to make sure that we're on the same page. So here's where it works. In this example, the user is using a mobile wallet, right? They download the wallet, they create their public and private key when they download that wallet. And they, with a tap a button, they're like, okay, this is my phone number. I want to request an attestation. They request an attestation from the smart contract, right? The smart contract will send back randomly selected validators that are going to perform the attestation service. So the wallet then, hits the attestation service for the randomly selected validator. Each validator is running their own attestation service, and it would reveal the phone number to the phone number that that they need to do an attestation on, and they sign it and they send a signed attestation via SMS message to the wallet. Once the wallet receives the message, it completes the attestation by signing its own message. So by there, you can prove that the validator, okay, this number has been signed by a validator who sent that number, who sent a text message to the number that's going to be registered, and that number completed it by signing it and sending it to the smart contract, and then we have it. The reason we do that is, like, you might think like, oh, why would anyone want to do it this way? The reason is, if you ignore the lower layer and you just do a wallet storing directly on a smart contract public key to, address to the public key mapping, you can attack the system by spoofing a lot of numbers, making up a lot of numbers and creating a lot of public keys and just mapping it out before real users are able to store that number and stuff, like their real numbers and stuff. So by performing the attestation, we can, we can verify that, okay, the validator was able to send a signed attestation message to the wallet, and the wallet completes the attestation with a signed message of its own. The smart contract can verify, okay, validator sent it, and it got completed by the wallet.
So this is really interesting. So maybe a few words on the relationship between the random selection of the validator and perhaps the stake of the validator. Is there a correlation if a validator has a higher stake, since you said the proof of stake are being used under the hood? So what's the relationship, if there is one?
No, that's a good question. So there's no relation between the stake and performing an attestation service. It's a requirement if you're going to be a validator to run an attestation service. There's no incentive yet, but we're working on an incentive mechanism in order to run an attestation service, so that if you are running it and you have high uptime, because we need attestation services to have high uptime, then it can really improve your rewards. And if you don't, if it's offline all the time, which means that it's impacting the network and the user experience, then it might decrease your rewards. And we don't do this once, by the way. We do it 3 times, like minimum of 3 attestations, completed, just in order to make sure everything is going well and stuff.
So this attestation is kind of separate from the actual validation of the information being added to the ledger. So those are 2 completely separate steps.
Exactly. The validator would have to run a validator node and an attestation service, what we call an attestation service node that is separate from that, but is just we have an expectation that validators have to keep both uptime, especially the attestation service, because that's what's ensuring users have a seamless experience when signing up and stuff, and to ensure that people can actually do attesting and stuff, because you don't want to randomly select a validator whose attestation service is offline. That's kind of like impact the system. But yeah, I mean, like the one thing I'm excited about is the incentives, because I mean, part of my job, because I focus on validators and node operators from a DevRel, is having to ping them whenever somebody's attestation service is offline. And I'd rather if there's an incentive where if it goes offline, that they can get impacted. And if they keep it online, all the time, they can get a reward for it and stuff.
So one final question, being a little bit more precise, what involves in that attestation? What are the steps? What are the exact things being validated?
Yeah, so what is attesting is just like a signed message. It's just trying to sign the message to make sure that it reaches its destination. Because in the first, when you're requesting an attestation, you basically let's go back here. You're trying to do address to public key. You want to register that in the smart contract. That's all you want to do, because all you're doing is you want to do a lookup table in a decentralized way for people to know this person's phone number maps to this address, and this is where we're going to send it to. But you also want to do it in a secure way, like in a way that can't be spoofed. So you send the smart contract, okay, I'm going to give this to these randomly selected validators. And all they're doing is they're sending a signed message using their private keys as a SMS to that wallet, and the wallet takes that message and completes it by signing it as well back to the smart contract. And the smart contract, knowing the person's public key and knowing that where the which validators were selected, it can verify that this this message has been attested. And if there's and if somebody sends like a spoofed attestation from separately, then it can know, okay, this didn't come from a validator, so we can't really accept that in the table and stuff. Cool. Is anyone else have any questions? All right. Going to the next step. This is, I'm not gonna stay too long on the reputation scoring, just because there's not online yet, and we're still trying to scope it out in terms of grants and stuff. But we have more information about it on the white paper, which I recommend if you want to check it out more at the white paper. But basically, with reputation scoring, there's a scheme called Eigentrust, which basically kind of score reputation of people based on their social network they're in, and in this case, phone numbers. So the people that I text all the time, I have a trust relationship with them based on my address book, and that can be scored in an eigentrust kind of mechanism. It also privacy preserving using zero knowledge proof. And the whole idea of this is that the more people who are doing attestation, registering their phone numbers and stuff, you want to have a reputation scoring around these, just what is valid, what is not, um, in terms of from the social network layer. Currently, it's still being scoped out. I believe we have a grant for it right now, and it should be the more growth we have on the mobile app, the more this is going to be likely going to be implemented and stuff moving forward. But the focus right now is on growing the user base, at least for the mobile app, before we can think about reputation scoring and stuff. Okay, so let's talk about the stability protocol overview. The stability protocol, we already brushed about stablecoin. We talked about stablecoin before. Stability protocol is specifically for Celo. We're going to give other examples of stablecoin designs, or what we call it designs, and before we talk about what Celo's doing. So there's several types of stablecoin, right? The first one is fiat collateralized. So where we talked about Tether and stuff, Tether, Gemini, USD, USDC, they're fiat collateralized. There's a one-to-one relationship, at least in theory, between the stablecoin being issued and being minted and what is backing it as a currency, right? It's like an IOU on a fiat currency backed asset and stuff. The good thing about this is, from an off-chain point of view, it's relatively very stable, because you just, as long as you're backing it with the the correct USD amount off-chain using fiat, this one-to-one relationship is the most simple and straightforward mechanism. Issues around it is because it's off-chain, you can sacrifice speed and stuff like that, because it might take a long time for you to convert your stable coin to the fiat currency backing it and stuff, depending on where it's being backed and stuff. So crypto collateralized stable coins, we talked about MakerDAO already and their mechanism. They're an example of crypto collateralized, and in the sense that they have Ethereum backing them as collateral. The issue with having a volatile asset backing a stable coin is that it might not behave very stable over time. It might not be as stable, just given the volatility swing might affect the mechanism moving forward and stuff. But it's still it can show you that you can, by having it collateralized to crypto, you're allowing it to be you're designing a more decentralized kind of approach around it. Finally, we have Seigniorage style. They have a specific mechanism that would contract or expand the supply of the asset, of the stablecoin asset, only if a certain condition are met. And this allows for if you have certain conditions in the market, it can expand or it can contract and stuff like that. And that would make it very useful and stuff. So Celo here, another thing about Seigniorage, if you have a Seigniorage kind of style behavior where you have an algorithm that can, if you have an algorithm that kind of defines it moving, the contraction and expansion of the supply of stablecoin, then it would necessarily need what we call a governance mechanism or a governance token or governance asset that is not necessarily stable, but it's what do you call it? It's in a way it can be volatile because it's the asset that you're speculating on. It can increase in value the more, you know, Seigniorage style stablecoin expands in, you know, in terms of volume, and it can contract as well. So Celo, at least the Celo dollar mechanism, it takes inspiration from all three different models. And this is what we're going to talk about next. It's using those three existing examples. Celo dollars had you know, takes the best out of all the world, in my opinion. So we can't really talk about like the stability fee without talking about what do you call it, the stability mechanism. And the stability mechanism requires what we call the Celo reserve. Celo reserve holds a basket of Celo currencies. Celo is the governance token that we have in the reserve, and then we have other reserves, other non-Celo reserve. We have Bitcoin, Ethereum, and DAI in the reserve. So it's a basket of currencies that we have in the reserve, and it gets rebalanced periodically and stuff like that, using the Seigniorage style, depending on the conditions being met. And the whole purpose of the reserve is to expand and contract in order to stabilize the Celo dollar that is being used, that we're, you know, promoting and stuff. And it has a stability ratio, and the stability ratio is 1. So basically, as long as the value of the reserve is equal to or higher than the stable coin issued, it's like that's this, you know, that's the what do you call the stability ratio. If it goes below 1, then we have mechanisms in place in order to increase the ratio back to 1. That includes the transfer fee on Celo can increase in order, and you know, the increase in fees can go back to the reserve in order to move the value of the reserve back to, you know, higher than the issued stablecoins. Also, epoch rewards. When you're doing proof of stake, some of the epoch rewards can be allocated back to the reserve just in order to stabilize the system. And we also have a stability fee on transaction added on top of transactions. So to talk about expansion and contraction of the reserve. So we have what we call a decentralized one-to-one mechanism. So users are, like we call it Doto, users can create, and this is, if you remember what we talked about before, like Fiat collateralized, this is our version of Fiat collateralized, where we have an on-chain decentralized exchange where it allows you to create new Celo dollars by sending the Celo governance token to the exchange and getting its equivalent value back in Celo dollars. At the same time, you can burn the Celo dollars by redeeming, you know, redeeming them for the value in Celo governance token. And because of this contraction expansion cycle, it gives a clear reason to do arbitrage. So if you're doing any kind of arbitrage behavior, it kind of keeps the system balanced. Like if you look here at the user, for example, let's say assume the price of Celo USD goes from $1 to 0.95 USD. Okay, so I'm a user. I go on the market. I'll buy a CUSD, one CUSD valued at 0.95 USD. I moved that Celo USD to the Celo reserve. Now here we're assuming Celo, and if you're kind of confused by CGLD, that's used to be the old ticker name. It used to be called Celo Gold, but we moved the gold part. Now it's only called Celo with a capital, you know, all caps. But let's assume the value of Celo governance token is $5. So here we already established 0.95 USD is the value of CUSD. So you buy one CUSD valued at 0.95 USD. You trade it at the Celo reserve for 0.2 Celo. That's $1 and $5. Then you can convert, you can send it back to the market and sell it back for $1 because the Celo gold is $5. So that gives you back $1. So what do you made a profit of 5 cents. Obviously it's like the simplest example, but that should show you like, you know, if in the contraction cycle, you can arbitrage the system in order to keep it stable and stuff, because there's an incentive for you to do that and stuff. Also, let's say the other way around, right? Let's say for some reason, the price of Celo USD is 1.05, like which is higher than the $1 peg. So you can you can send the 1.05 to the market. You can send it to the market over, and you can convert it to the Celo gold and stuff at 0.2 Celo gold, and then from the Celo gold, you can convert it back to convert it back, and you can also make a profit that way. 5 cent profit, because you're playing the opposite game that you're playing the previous slide, the contraction and the expansion cycle.
So wait, is the ratio between Celo Gold and Celo USD constant, or do you guys ever change that?
That's a good question, but no, there's no ratio. But the rate, this is more like an example for if we presume that one Celo gold, like Celo, one Celo is $5. That's why we have that ratio to 5, but it's not the rate, like the price is always determined by the market for the Celo governance. And the more that Celo USD is being used, the more it's being minted, the more the value would increase for Celo, the governance token, just because of the Seigniorage style that we highlighted before and stuff. But the ratio here is just for the example. It's not constant or anything like that, because the Celo price is determined by the market.
Okay.
So we have like an additional thing on top of that. So the ratio, the fixed ratio that you asked, we do have that when we're doing like, keeping stabilizing the market, at least for the exchange here. We have what we call a constant product decentralized one-to-one mechanism, which is the constant product idea is inspired by Uniswap. In Uniswap, when you're having a liquidity pool, let's say Ethereum to DAI is like, the liquidity is like the constant product is about 5. So like 500 DAI per 1 ETH, that's like that, or sorry, that means that'll be like a 500 to 1. If Ethereum price goes up, the amount of the requirements in that pool would have to be matched just to maintain that ratio, and that's what the constant product is. So we took that idea in order to secure the system that we have in the reserve, and the idea being is there's several ways you can attack the reserve. Because the reserve needs to look up the price of Celo governance token on off-chain exchanges, it needs an oracle. So let's say I'm an attacker, I can go after the oracle, control the oracle, and hack the oracle and modify the price of Celo from 5 to inherently 0, and then I can just, trade it for USD. Because I modified the price to be really low, I can, for a small amount of USD, CUSD, I can get a lot of Celo gold, right? Based on that mechanic, right? And then I can sell that in the market for major profit because I exploited the oracle price. We try to avoid these kind of attacks and stuff, and the oracle being the biggest one, by using the constant product. So the constant product allows you first, you don't have all the entire liquidity being traded, only a subset of that liquidity is being traded. And then we try to dynamically adjust like the on-chain prices by having the constant product market maker. Like in this example, you want to have like if you want to have like pre-contraction, post-contraction at 5, just to adjust the price based on demand and supply. At the same time, you don't want it. You want to make sure that one part of the liquidity being provided is not like too abnormally high, or there's too much happening on one side of the liquidity compared to the other, because that can indicate there's a problem, as in like the Oracle example, like hypothetical example that I provided. Okay, with that, we can go to consensus as a mechanism. So with consensus, we can talk about, like brush over what the consensus mechanisms are and stuff like that. And this is normally my favorite part. So we're in a proof of stake network. So for the proof of stake network here, I don't know if like you ever really brushed on proof of stake before, but the idea is like, you have a certain amount as a validator, as a node that you're staking. And depending on who gets picked next, like, they shuffle the validators, and whoever gets picked next will have to propose a block, include transactions in it and stuff like that. And then, submit it, folks, all the other validator accept it. And, that would allow you to, stake your coin, earn a reward on it and stuff. And you're helping secure the network in an environmentally friendly way. Compared to proof of work, where, it's more in a way, if not really randomly shuffled, but it's like who comes up with the first solution to the problem, like the proof of work, who, comes up with the first proof of work first can submit that block in a more competitive fashion and stuff. Yeah, so we're gonna go more on the proof of stake part.
Wait, so are the gray validators just the ones that haven't been selected, or
Okay, that's
so it's a random?
Yeah, so I was gonna go over that later, but I can talk about that now. So here, what we have another thing called validator groups. So validator groups is kind of like, say like, it's like an organization in a way. You have an organization on chain that you can vote for that group and stuff. And each validator group can allow up to 5 validators that you can elect into that group. And that kind of thing is just for people to know that you're an entity as a brand and stuff, because the reason, you have groups is because you want to be able to advertise, oh, I'm a validator with this organization and stuff. And, the Celo owners can nominate you and stuff, or they can delegate their stake to you in order for you to validate and earn rewards for them, and you earn separate reward as a validator and stuff like that. So here we have up to 5 in a group elected. We have a slot up to 100 validators, not 100 validator groups. So you can have up to 100 validators in the system. We have governance ideas to increase the slots of how many validators can, validate and stuff, but currently the cap is at 100. And each one has 5. And the validator group doesn't exist in other networks. It's something that we came up ourselves, just because it allows you to like in other networks, if you don't want to avoid being centralized by whale, a whale would be able to, take up all the validator slots and stuff anonymously. Just, elect a validator, you just have a public key of the validator, and that's that. By having a requirement for validator group, it kind of shows who they are, right? And you have a minimum of 5. So it's a higher cost for you as a whale to create a separate entity, and elect another validator group, and then from within that validator group, elect, stake for, elect more of your validators under that group and stuff. It's just, there's a higher cost there, because it's kind of like, it's kind of similar to setting up another organization just in order to validate more and stuff like that. Hope that answered.
Okay.
Cool.
Yeah.
All right. Let's talk about the consensus mechanism itself. It's called IBFT, Istanbul Byzantine Fault Tolerance Consensus. I'm going to brush over it quickly. I think if the best resources on this is just like the paper and the EIP that proposed it. It was originally proposed by Quorum, which used to be like a group under JP Morgan before JP Morgan sold them out to Consensus. But IBFT is basically this. We start off here at the new round for everyone here. So in the new round, a validator gets randomly selected in a round robin fashion, right? So you have that new round. The validator gets selected, right? When they get selected, they do what we call they become what we call the proposer. They're proposing a block to broadcast, and when they propose the block to broadcast, they have transaction that they want to include in that block that they're proposing, right? They submit what we call a pre-prepare message, like, oh, before you prepare, just here's a heads up that you have to prepare, right? And we get to the pre-prepared stage. In the pre-prepared stage, we have to check that we have to check that everyone, once we get to the pre-prepared stage, we have to wait for folks to send us what we call, that's the prepared stage. In the pre-prepared stage, we have to make sure that the proposal is valid and there's no timeout on it, just in case they go offline or something. But once you get to the pre-prepared stage, you would have to broadcast the prepare message. The prepare message is basically, I'm telling all the validators in the system, like, all right, I find this is my proposal. Please prepare in order to approve this block and stuff. And we have to wait for 2f+1 messages. So what is f? F stands for the faulty number of node tolerance. So how many nodes can you, faulty nodes can you tolerate in your system going offline? So in our case here, we want we have 2/3 quorum. So if 2/3 or higher, we have quorum. So that means that F is about 33 nodes. How much node can we tolerate being offline in our system? 33. So we would have to wait for 33 times 2, 66. So 67, we're waiting for a minimum of 67 nodes, a validator node, to tell us that you're good to go. That's how we determine quorum. So once we get once we wait for the prepared messages from all the other validators, we're ready to broadcast the commit message. We're like, okay, y'all ready? Let's commit this. We broadcast the commit message, and again, we wait for validator to confirm, okay, yeah, we're good to go on committing this. Once we get 2f+1 again, we can then insert the block into the system. Right. So once we insert the block, just make sure that the insertion fails, succeed. And if it succeeds, we have finally committed a block to the ledger, and then we jump to a new round where a new validator gets selected in the round robin fashion and stuff.
Okay. How do you check if the insertion fails?
That's a good question. I think in the paper they would go more over it and stuff like that. But let's say something can happen, I guess, in between those steps where a node can still go offline before inserting and stuff. So that could be one of the things that are happening and stuff like that. That you want to make sure that the insertion succeeds and everyone.
Okay.
See, I'm I think for this one, for more detailed and checking out the code, I highly recommend the paper, at least for IBFD. We had Quorum and other folks who worked on that before, and it was just something that we adopted as a consensus mechanism because of it being very useful for our use case.
Any reason for picking IBFT instead of PBFT?
I think with Istanbul BFT, That's a good question. I don't know if I have the answer because I think the design decision about between IBFD and PBFD happened before I joined, and like I don't want to like answer wrongly and stuff. But that's a good question. I should know this.
Yeah, no worries. Thank you.
Okay. Any more questions? I'll try my best to answer. Okay. We're just going to brush over node discovery right now. It's not like something I want to brush over too much, but I just want to point out as discovery version 4 is what we're using, which is just based on Ethereum discovery mechanism, which is basically, let's say I'm starting a node, what happens? What happened when you run a node for the first time? The node software had what we call boot nodes that are already within, like they're already inserted into the blockchain, like into the blockchain client. And they have an address, they have like the enode address. So we know like when the new nodes start in node, who to hit up first. Boot nodes are basically, think of them like the guide to the whole network. They're like, all right, here, I'm the boot node. I have a directory of all the other nodes in the system. Here's who you should be peering with just to synchronize, in a distributed system in order to sync and, get blocks and stuff like that. The boot nodes, give you all the different nodes in the system that it stores and stuff, because it's just like a node that helps you, bootstrap the network. It's modified from the discovery for v4. There's a modification here where we tell it to look at the network ID. Now, looking at the network ID is important. And I think it's like, frankly, is super important. I don't know why they don't do it in Ethereum, but the network, we try to make sure that the network ID we're trying to sync with matches the network ID of the boot node on the client. Otherwise, if we don't have that check, because of the discovery v4 protocol, we can technically look at non-Celo network nodes and try to peer with them and make sure that we, so in theory, you can technically peer with Ethereum Classic node just because of discovery v4. So by having that check to be like, okay, make sure that I'm only, peering with nodes that have that network ID, and make sure that we're not wasting a lot of work and time peering with useless nodes that are not going to give us the right, block number, the right Genesis hash and stuff like that. Validating. So we already talked about this before, but it's like 100 validator cap. Epochs are 1 day, so every 24 hours, you get the rewards and stuff. We already talked about validator groups. Mo, I believe I sent like presentation, but if anyone's interested, the webinar, there's a URL, it's like a YouTube video and stuff. Everyone wants to check it out later.
Yeah, I will be posting that. I received it. Thank you so much.
Awesome. Thank you. Yeah, this is just one last thing on like the consensus. One other thing that we do is called governance. Whenever we have a proposal to submit, there's like what we call a governance proposal. And governance proposals are voted on by the users. It allows you to like, as a user, you can, vote on a proposal, like to update the system, to change contracts and stuff. Some proposals that we're seeing, like, we're talking about is maybe having an alternative stable coin other than US dollar, maybe euro and stuff like that. And you can do that by, you're delegating your vote, which is your Celo token, to the validator group of choice. And, from there, they're electing the proposal and stuff like that. At the same time, this is also how elections happen. If I want to nominate a validator to be a validator, or at least allocate Celo to a validator group in order for them to get a new validator, because for every validator you include in the system, it has a cost to it in Celo. So governance is where we do these things. So we're going to talk about mobile first. So like the whole point here is like, why is Celo different than other chains? And the most important thing is like, because we're a mobile first network, we already talked about the attestation service, something that other networks don't have, and it could improve the user experience so much, at least because you don't have to fully rely on using public keys anymore. You can just, text people like and send money via text on chain. So why are we mobile first again? The reality is there are more mobile users globally. In more developing world, like countries that are still in development stage, a lot of them have gone from no computers to having a smartphone within from 0 to 1 in a way. And mobile smartphones are more accessible to everyone. A lot more people are getting access to smartphones around the world. And while they don't necessarily have to have a laptop or a computer or anything, but they would have a mobile phone. Also, from a UX UI perspective, it has more reach. It's just more intuitive for users compared to using the command line and just being somebody with really specialized knowledge in order to participate in the blockchain. With a mobile phone, as your user experience really improves. Also, we talked about emerging markets. A lot of them are using, mobile, they're mobile first and stuff like that. So that's like a very attractive choice just to focus on being mobile first as a blockchain. And that's where we go over Valora. I apologize for the photo. It's supposed to be a GIF, but I saved it as a PDF and it doesn't really render the GIF. But it's supposed to be a really nice GIF to go over. But I do recommend checking out valoraapp.com. We just recently redesigned it. And we have now it's available on iOS and apps like the Google Play Store. So you can download it right now. Valora is kind of like, and you mess around with it. If you have more questions about Valora, please message me after and stuff like that. It's kind of like Venmo. I'm actually kind of curious if people are like, if you're interested, you can use it and stuff like that. It's free to download, so. Now let's brush over simple comparison to other networks. I don't want to delve too much into it because there are a lot of differences rather than similarities. So the first difference is we're gonna talk about Polkadot. So Polkadot, because it's proof of stake and stuff, Polkadot has a really different architecture. Celo is kind of like a fork of Go Ethereum. At least we talked about it being EVM based. We talked about the proof of stake, smart contracts and stuff. Polkadot is basically, the parachains are trying to do sharding and stuff. And sharding is just a fancy word for, side chains. And so the parachains are side chain, but each side chain has its own consensus mechanism, its own log, its own applications and stuff. And then you have what we call a relay chain in Polkadot, which kind of is like a global state that, in which all parachains can, interact with and stuff using the relay chain stuff. The other thing about Polkadot, it has parachain slots. So instead of validators, you have a limited capacity how many networks you can run on Polkadot. And it has communication between parachains, where Celo is just it doesn't really do side channel, even though technically you can build a side channel or a side, side chain. And Polkadot also has what's called grandpa consensus, which is what's governing the relay chain and allowing the relay chain to interact with all this minimal, it's like a parent chain interacting with a children chain being the parachains. I don't know enough about Polkadot to answer any question, but I would recommend reading more on Polkadot differences with Celo. But this is where, from a high level, what we go over and stuff.
Yeah, we actually we're fortunately had a dedicated lecture invited talk on Polkadot and Near as well too.
Awesome. Yeah, that's good to know. So I don't have to answer any questions on Polkadot. I love it. The other one I want to talk about is Cosmos. Cosmos is actually kind of it's going after what it called a unified API for hubs. Hubs are kind of like parachains in the sense in which that it's there's separate networks on their own and stuff, but using a unified API called the IBC is trying to do what do you call it? It's like an API standard that allows communication between different hubs, between different Cosmos hubs. But it's permissionless hubs, so there's no slots like what we have for validators here or what we have for Polkadot. It also has something called the ABCI spec, which allows for I believe it allows for like your hub communication with your DApp state in a way, but like from a high level, I'm probably butchering the concept. I'm not the biggest expert on Cosmos, but this is it from a high level. Now, finally, let's go to case studies. Case studies, so our team at ExpoLab, we've done a lot of case studies. Like, we talk about, we want to create the condition for prosperity. And one of the ways we want to do that is we want to travel to emerging markets and try to test what are the user needs. Like if you're like at the poverty line, or how would like a stable coin or anything like, really impact you? So we did what we could, a Philippine pilot. We went to the Philippines and we did a pilot there with 23 testers. They're all low-income fast food workers. So they're all working in the same place. And they all were connected to, like they work close to like 5 stores, 5 merchants. So we wanted to enable them with an app, with the Valora app, just as a pilot test on a test network, to see how they're using it and stuff like that, as digital payments and stuff like that. We want to understand how they're using electronic payments and stuff. And this is the team that, we worked with and stuff like that. They're super friendly folks. So the insight we got here is like the main insights are like, slow internet affects transactions. Like they have to wait a while for transactions and stuff. To go through just because of how slow the internet is. And Philippines has like compared to other troubled regions as well, Philippines can even have even slower internet. Like I heard like internet in Zimbabwe and Syria are faster than Philippines in a way. So slow internet affects transactions. So if you're trying to sync the node, you're trying to sync the network on your phone and it's really slow, it can really slow down your transaction. And that's the main one of the main insight that we got and made us want to think about, we really want to make sure it's so lightweight and that we're able to sync the network fast, which is why we want to build, we built the light client. And we're working on a light client for that. That would allow to sync a lot of blocks really fast. Also, other issues that we saw with outdated smartphones that wouldn't be like, there's like outdated software in them and stuff like that. And that would make it kind of difficult for it to work with the application just because it might be slow or like, just like something can get broken. The main interesting thing that we saw is Filipinos, at least they like to conserve data within that pilot study. So when they're not using their mobile data, they turn it off. And they only turn it on when they need it and stuff like that. So that kind of gave us a lot of insight about, how people use their phones in like emerging markets and stuff like that. And also they have low trust. So they didn't understand the whole idea like, oh, what do you mean? Like, you can use my phone to pay and stuff. And they didn't like, at the beginning, they didn't really trust it. And they were like slowly coming to like, try to use it and try to accept it and stuff. And it gave us a lot of, information and insight. And like the Philippines is one of the markets that we try to target, at least, for the future Valora and stuff like that. So it's something that we really want to continue working with as a country. The other pilot is Kenya. So Kenya is super interesting because of M-Pesa. If you haven't heard of M-Pesa, M-Pesa is kind of like, imagine them like, kind of like allow you to send money via phone between people, but only within a region, within a country. So it's popular around Africa, but you can't necessarily use M-Pesa in Kenya to send it to M-Pesa in Nigeria. You would have to like, withdraw the money at your local M-Pesa in Kenya, and then, deposit that money in Nigeria, and then you can use M-Pesa again. But Kenya has 86% adoption rate of M-Pesa. So a lot of people are open to the idea of using cell phones and just to do transfers back and forth and stuff. So we decided to work with 24 Kenyans, at least for interviews here. Middle class, rural, and or urban poor class. And just to see just like, the people who are like, you might need it at first. We also wanted to make it a diverse age group and, both, male and female, just to get everyone's point of view as well. So the insight that we got here is like it has to speak to the people's need, right? So they don't really use something just because it's like, oh, it looks cool and stuff. It has to speak to the need, right? So with M-Pesa, they're like, it allowed them to send money back and forth, and that spoke because like they needed to do that and stuff. Um, the way they understand things, like when we gave them this new kind of technology and stuff, is they like to put those new concepts in old understanding, like, oh, this reminds me of this old thing that I'm used to and stuff like that. They don't like that the way they're at with it. And they prefer things, they like to use things with word of mouth. So with M-Pesa, what we understood from M-Pesa is that they have a word of mouth, like somebody tells a friend, oh, I'm using M-Pesa, and it slowly kind of goes exponentially from there in terms of word of mouth. And they trust people over organization. There's more trust among their community of using these different technologies like M-Pesa over different organizations. And that really informed us a lot about Valora and how to target it and stuff. And because we're like early on in Valora stage, it's like we have like a lot of plans for this, like expanding and like growing the user base, especially in places that are in need of these technology. So yeah, I mean, yeah, now, thank you so much for like, taking the time to go over the lecture with me. If you have any questions I can't answer in this lecture, hit me up on my email, or this is my Twitter handle, and I'm more than happy to answer any of your questions. But yeah, I mean, the floor is all yours.
All right, thank you so much. Let me take this opportunity and on behalf of ExpoLab and UC Davis to thank you for this wonderful and detailed lecture. Thank you so much.
My pleasure. Thank you for having me.